Bismillahirrahmanirrahim. Exercise 3.4, question number 2, part 7. Integral e to x cos 3x dx. The formula for integration by parts, considering f as first and g as second function, is first function constant integral of second minus integral derivative of first into the same integral. Then we close the bracket and then we write dx for this integral sign. The previous knowledge which we need here is d by dx of e to power 2x equals to e to power 2x into 2, and you may write it as 2e2x. Integral of sine 3x dx is minus cos 3x by 3 plus c, and integral of cos 3x dx equals to sine 3x by 3 plus constant of integration. Let's start the solution. Let's name the integral as I equals to integral e to x cos 3x dx. We are going to perform integration by parts, considering e to x as first function and cos 3x as second. So let's perform integration by parts, and I get integral I is equal to first function constant integral of second minus integral bracket starts derivative of first function into the same integral cos 3x dx, bracket close, and I have a dx. Now write these results from here and you will get e to x integral cos 3x dx is sine 3x by 3 minus integral derivative of e to x is 2e 2x, integral of cos 3x is sine 3x by 3, and then I have this dx. So I just write all this like this, e to x sine 3x whole by 3 minus, I bring this 2 outside, I bring this by 3 outside, and inside the integral I have e to x sine 3x dx. Now what do I do? This was my integral I. So I am writing it like this, e to x sine 3x by 3 minus 2 by 3 I1, where I1 is equal to integral e to x sine 3x dx. And for further reference, I'm going to name this result as 1. And now I'm going to perform integration by parts for I1 using e to x as first function and sine 3x as second function. So I get, I integrate by parts, integrate by parts, and I get I1 is equal to first function constant integral of second minus integral bracket starts derivative of first function into the same integral sine 3x dx, bracket close, and I have a dx here. Now write the results from here and you will get e to x integral of sine 3x is minus cos 3x by 3. So I use a bracket minus integral. Derivative of e to x is 2e to x, and integral of sine 3x is minus cos 3x by 3, and then comes this dx. So what do I get now? The value of my I1 is minus e 2x cos 3x by 3 minus, and this minus comes outside, so I get plus. This 2 and by 3 comes outside, so I have 2 by 3, and inside the integral I have e 2x and cos 3x. E 2x cos 3x and dx. And now what? Just look here. What is this? E to x cos 3x dx. It is in fact I. So I'm going to write I1 is equal to minus e to x cos 3x by 3 plus 2 by 3i. Now see, we don't have any more integration to perform. It means we had performed our last integration. Where did we do this? This was the step in when we performed the last integration. So we must introduce a constant of integration here. So I'm writing a constant of integration as C1. I better write it down. I'm going to write C1 here. I'm going to introduce a constant of integration in this step because this was the step in which I performed the last integration. So I must introduce constant of integration here. So I've added a C1 here, I added a C1 here, and I added a C1 here. Now bring this 2 by 3. Now what is it? Now we are going to put the value of I1 in result number 1. This is our result number 1. Put the value of I, and this is the value of I1. So I get I is equal to result number 1 is I get I equals to E2x sine 3x by 3 minus 2 by 3. In place of I1, I have these two values, this value. So I write it there, minus E2x cos 3x by 3 plus 2 by 3i and plus C1. So open up the bracket now and you will see I is equal to E2x sine 3x by 3 minus and minus plus 2 E2x cos 3x by 9 and minus and minus, minus and plus give me minus, minus, and I have 4 by 9 I and minus 2 by 3 C1. Now what do? I'm going to bring this minus 4 by 9 over to this side. As a result, I'm going to get I plus 4 by 9 I here. And on this side, what do I have? On this side, I have E2x sine 3x by 3 plus 2 times E2x cos 3x by 3. So I think I can take something common. What can I take common? I can take E2x common. I can take by 3 common. I can take these two things common from here. So I take it common. Inside the bracket, I have sine 3x. And from here, I have 2 cos 3x by 3. This minus 4 by 9 has gone to this side. And then I have minus 2 by 3 C1. Now, what we are going to do, perform this addition, and I'm going to do this addition in the rough work. So I get 1 plus 4 by 9. It is equal to 9 plus 4 by 9 taking LCM, and I get 13 by 9. So I have 13 by 9 here with I. It is equal to E2x by 3 sine 3x plus 2 by 3 cos 3x, and then I have a minus 2 by 3 C1. Now multiply both the sides by 9 by 13. As a result, you will have to multiply 9 by 13 here, and also 9 by 13 will be multiplied with this minus 2 by 3. So I'm making some space for my minus 9 by 13. I had minus 2 by 3 C1. I have to multiply it by 9 by 13. So what happens? I get this cancelled. I get this cancelled and a 3 here. And what happened to this one? I'm going to write it in the rough side, in this sidebar, minus 9 by 13 into 2 by 3 C1. It becomes, here it is, minus 6 by 13 C1, and I'm going to put it C. directly in place of this minus 9 by 13 into 2 by 3 C1, I'm in place of this directly I'm going to put C, and now I will get this thing. I is left here. Here I have 3 by 13 e to power 2x. Inside the bracket I have sine 3x plus 2 by 3 cos 3x, bracket close, and in place of all this I have a constant of integration, and this is my answer. That completes the solution.